How's it going, you guys? It's Scott with Everyday Home Repairs. Let me show you how to mount a flat screen TV on an exterior wall, and this is pretty much exactly the same process if you had an interior wall. And more specifically, how do we power this without using extension cords dangling across our property or dangling across a room? How do we reposition that where there are no power cords and no extension cords that are visible? Let's jump into it. So before getting our outlet exactly at this location and eliminating that extension cord, let's get this mount, the actual thing that's going to hold our TV securely on the wall. Specifically, a lot of these mounts now come with the ability to extend them away from the wall surface and pivot them so you can see at different angles. In that case, you are going to want to make sure that you are sinking actual lag bolts into the wall. Now, this came with the kit. Do not use any form of anchors. And remember, on an exterior wall like this, we will have sheathing on the outside. So we will have some type of OSB or sheathing product on the outside of our stud wall. We do not just want to go through the sheathing. We need to hit 4 lag bolts into our studs. So it's critical that we actually locate the studs and make sure we have those secure attachment points. Now, I know this wall is 15 feet side to side, so I'm going to get a reference dimension here, hooking on the wall, and then going out to half that dimension, which would be right at 90 inches or 7.5 feet. So I'm going to mark that. That's going to be my side to side. Now, to get your vertical, where do you want your mounting location? You need to reference both your TV and also your mount. Remember, TVs will attach at different points, so make sure you understand how far past your mount is your TV going to go. That's a critical dimension to know where should you mount this on the wall. Now, you need to find those studs, and especially on an exterior wall, it's not as easy as using a standard stud finder. I always use the Stud Master here, which is a magnetic stud finder. That is completely useless, especially on stucco. There's usually chicken wire behind that, and it's simply not going to get the fasteners that attach the sheathing onto the studs. So I need to get a reference hole coming from the inside to the outside, and then that's going to locate my stud, and then I'm going to know my spacing so we can get all 4 of those lags in place. Now, I have an unfinished walkout basement here, so wide open studs that I can reference my marks from the outside, knowing where to drill by to locate the stud. With this location hole through the stucco, now I can measure over 3/4 of an inch or half the width of a stud and drill my hole through the stucco as large as the lag screw. Then a smaller drill bit for a pilot hole for the lag, get my mounting bracket and sink my first lag with my impact driver, tightening that up so then we can check with the torpedo level to make sure everything's level before locating the other 3 mounting holes. When everything looks good, we'll check our 16-inch on-center spacing, which is the spacing between my studs, and most construction we'll use 16-inch on-center spacing for wall studs. Loosen up that lag to get the bracket out of the way, and now we have our 3 other holes that will drill our larger hole with our hammer drill, and this is a rotary hammer drill, so it makes quick work of those holes, and then the smaller drill bit to give the pilot holes to the lags before we sink them. So loosen up the one lag, tighten that back up, and start to sink our second one. But before we tighten everything up, let's check that level one more time. Once it looks good, then we'll tighten up our 2 before setting our 3rd and our 4th lag, with this being our finished result. So now moving on, I'm drilling from the inside again with my rotary hammer drill. This is a little dangerous, and you're going to see why. This is locating our junction box. But with a rotary hammer drill, you can have blowouts very easily like that. Now, we'll try to account for that with repositioning the box a little bit and the cover. We'll see how we do by the time we get done with the project. So I'm just marking around that south wire box that I'm going to use, and then I'm going to use my angle grinder here with a masonry blade, and you'll see me coming in with an oscillating tool as well. 3/4 of an inch of stucco is one of my least favorite to cut out in terms of getting the exact size hole for that box. But if you take your time and have a little patience using your diamond wheel and your angle grinder, that'll do most of the work for you. Don't forget to reference while you cut exactly the size of that hole so you do not overcut, because if you overcut or position this hole in the wrong location, it is a little hard to undo that, and you might have a lot bigger project on your hands. Now once you have it sized correctly, now I'll go ahead and tap my south water box in, and I did swap out the standard Phillips head screws for some better general purpose with a T25 torque bit. And now for the wiring portion, pretty straightforward, and I have the insulation moved out of our cavity so we can see what's going on. We have a 14.2 Romex coming down. That's what I'm going to use to power the outlet outside, which is going to be right in this junction box that we see on the back side now, the one we just installed. I'll take this existing 14.2, I'll route it first to the junction box here. I'll power the GFCI weather rated outlet, and that's going to be in the line side of that outlet. Then out of the load side, I will take a new 14.2 piece of Romex. I'll run that down to our existing box, and I'll power this standard outlet again, and that will be protected with GFCI protected. It's in the basement, it should anyway, so that'll add some additional protection there. Pretty straightforward wiring, and I'll use my Klein Tools ET310. This is nice because it actually helps you find the circuit breakers at your panels. You can plug in the outlet portion of that and it'll test your outlet. So I'd plug that in here. Now that's powered on, and it's giving a signal where I can now use this end of it, which is the receiver end. You can hear it beeping. I can go over to the panel and it'll start increasing the frequency of the beep when I get close to the breaker. So it's just much easier to find that breaker to turn off, so we can turn off this circuit and work safely. And if you need reference to the Klein Tools ET310 or any of the other tools I use throughout this video, you can check a link in the description right below the video, or if you're watching on your TV, you can scan this QR code and it'll give you the complete list for your reference. Also, you'll see a link to our 2025 updated home maintenance checklist. This is a great checklist just to have on your refrigerator. It has your monthly, seasonal, and yearly tasks that you should be staying on top of, and just a nice little nudge and reminder on what are those items that we need to be doing on a regular basis. So let's jump into the wiring and finish off this project. So first up, let's take that existing piece of Romex, pull it back up through and into our new junction box that will have our exterior GFCI outlet. I'll go ahead and place 2 staples here to secure the Romex within 6 inches of that box, which is code. We'll remove our old 15 amp outlet here, and this is what I want to run new Romex from this to this outlet, and then back up to that junction box that will have the GFCI outlet on the outside powering our TV. Here's the new Romex we brought in, and this is 14 gauge because it's a 15 amp circuit. I'll cut it to length, and then I'll use a Wago 221 lever nut to pigtail my ground, and I'll put a little J hook in it. Now I'll just keep my neutrals and my hots. Neutrals are white, hots are black. Those will be straight. It's because I'm using the back wire feature. This is not backstabbing, which is what that outlet we removed was using. This is called back wiring, and it's available on most commercial grade outlets. Again, you'll see that link in the description for the supplies and tools that we're using. Tuck everything back in, and the Klein Tools multi-bit makes quick work of this, where you have all the bits you need without swapping out screwdrivers. Now bringing that new Romex 14 gauge back up, and also wheel secure again to the stud here, and then going on the outside after putting in our insulation because the wiring on the inside is all done. Cutting into length, you want at least 3 inches out past the edge of your box and 6 inches from the end of your sheathing that you're cutting off there. And then we'll strip those all out, again holding them straight because I'm going to use a pretty sweet Leviton GFCI, which is also weather rated and tamper resistant. We'll pigtail that ground and everything goes straight in, and it just uses levers. Actually, there are no screw terminals to tighten up, which make these very, very convenient to use for DIYers, and I highly recommend. Now this cover is an in-use cover, so we'll tighten down those mounting screws, which also tightens down this cover, and it has a little gasket there where you can keep a plug plugged in, and it has the clearance with the wire coming out the side. So hopefully that helped you out on your own project, and let me know down in the comments if you have any questions. I'd be happy to help you out. Now, if you have a similar project, but you need to move the outlet a little bit further along your wall and you don't have wide open access on the backside, check out this video right here. I'll show you a few tips and tricks that makes that project much easier and keeps you out of doing drywall and not doing painting, keeping you out of the attic and not even going down in your basement, doing all that within the room and keeping it as clean as possible. So thanks for joining me on this video, and we'll catch you on that next one. Take care.